And on to more applications with right triangles. Yay. So this first example, you can pause the video, read it if you wish, but the idea is that, um, we have an observer standing 30 feet away from a building. So, and we're also talking about their perspective, their line of sight. So this distance here is 6 feet, okay? But the total horizontal distance that we're talking about is 30 feet, okay? But then anyway, if they go up, if their eyesight were to go up just 6.1 degrees, okay, they'd see the bottom of the window. And if they elevated a total of 20, so this whole angle is 20.1 degrees, then they would see the top of the window. Okay, so imagine there's a wall here, here's a window, but we'd have, bottom of the window and then top of the window. Okay, we want to know how much or how high the window is, so from there to there, and so to the nearest tenth of a foot. Okay, well, this is going to be interesting. Okay, there's a lot going on here, right? We have really just one right. Well, we might have a few right triangles that we could talk about. This right here, where the window is on the wall, that wall we would assume is perfectly vertical. So if we look completely horizontal and then up, that forms a 90-degree angle. Okay, so we have kind of two triangles going on. There's one, which is this smaller one. I'll outline it in purple. Okay, so it's this small one. Okay, if I expand that out, it looks something like this. Very small angle. Okay, so there's that, and we know that this is 6.1. Okay, and this would still be 30. So 6.1 degrees and 30. Okay, and then the other one, I'll outline in red, is the big one. Okay, and again, expanding that out, this would be the 20.1 degrees, right angle, and 30 degrees, or 30 feet. Okay, so what is it that I have and what is it that I want, right? There's a lot going on here. Okay, well, I want to find y, but what I notice is that there's a few different, like, other vertical dimensions, right? So I can find this part, so let's call this y1. That would be right here. I can find that height. Okay, sine or tangent, and I'm good to go. And then so I have like y1 plus y is equal to this whole thing, which maybe we call that just like total height. I don't know. Um, so is h. Okay, we'll call it y2. Why not? Okay, and that would be right here in this diagram. So in other words, if I can find y1 and y2, then I can find y just by taking their difference. Okay, so I can find y1 by doing tangent of 6.1 degrees is equal to y1 over 30 multiplied by 30. So y is equal to 30 times tangent of 6.1 degrees. And if I round, I'm going to hang on to 2 decimal places, or sorry, this is y1. Actually, I'm just going to round this at 3.2. Okay. Similarly, in the red triangle that I have here, I would have tangent of 20.1 degrees is equal to y2 over 30. So y2 is equal to 30 times tangent of 20.1 degrees. And I get approximately 10.97 for this, or we can say 11. So approximately 11. So then if you take their difference, right, y is going to be y2 minus y1. So then y is approximately 11 minus 3.2 or 7.8. Okay, and so I would just make sure to write a sentence. The window is approximately 7.8 feet high, just to wrap things up. But again, in this problem, my God, the diagram was perhaps the most confusing thing to set up. Just making sure that, I have 6.1 degrees shown to the bottom of the window, and then 20.1 degrees in total, not in addition to, but in total, for the angle of elevation to the top of the window. So be careful with that. Now, you might be wondering, why couldn't you just, take the difference and then in the middle here, just from like the top of the bottom to the top of the window to the bottom window, that's 14 degrees. Why couldn't you just do like tangent of 14 is equal to y over 30? The thing is, we don't know if that's a right angle, okay? So that might not be 90 degrees, okay? We don't have enough information right now to do that. You could do a little bit more geometry for sure and get that, but I think in the end you'll find out that it's not 90 degrees, and we don't have tools yet to be able to go further in a non-right triangle case. Okay, more on that in a little bit though. There might be a law of sines or cosines in the future that we could use. All right, next example. Okay, talk about a roof of a house. So take a minute, pause the video, read the prompt. So we have a roof of a house. Okay, so it's in the shape of an isosceles triangle. We're going to call that isosceles. Okay, so whatever this length is would be this length. What else do we know? Where its height is 6 feet. So right down the middle, that's 6 feet tall. That'd be a right angle. When we divide an isosceles triangle in half, it's a altitude, so it divides it perfectly in half, and it's perpendicular. Its base is 16 feet. When we divide it, those two sides are congruent. So this is 8 feet, and this is 8 feet. And it says, what is the pitch angle of the roof? Okay, now this one, I should mention that this example is optional. Okay, it's a fun one. But again, we're going to have to use an inverse function because it's asking for the angle. We'll worry about that when we get there. Okay, this angle here is going to be our pitch angle. Okay, in the parentheses there, it says the pitch angle is the angle that the roof makes with the horizontal. So the roof is L, and then the horizontal would be that 8 or that 16 feet across. Okay, so how do I find theta? Well, I can see that if I look at this, like 1/2 of the triangles, or a half of the overall isosceles triangle, that is a right triangle. And in that situation, I can say tangent of theta is equal to 6 over 8. And then I would normally be stuck, right? Like our knowledge doesn't allow us to undo trig functions right now. But again, if you have seen inverse trig functions in the past or know about inverse trigonometric functions, you can say that you can find theta by applying the inverse function, inverse tangent, arctangent, so to either side. And then inverse functions produce, and you're left with theta on the left, and then you have tangent inverse on the right. And there you go. If you, to the nearest 10th degree, so if you approximate this, you end up getting 36.9 degrees. Okay, there's a button on your calculator for inverse tangent. Okay, and then you just have to make a sentence. So saying the pitch angle is about 36.9 degrees. And then you're done. Okay, so again, this example is optional, but it does give you another possibly tool in your toolkit a little early. Just kind of understanding the idea that, okay, if you need to find an angle, you can undo a trig function with its inverse function. But other than that, get your diagram set up carefully and have fun with application problems.